Okay, so I thought like maybe it would be best if like we just go through them and then just say what we got for our answer. And if we have the same answer, we can probably assume that we've got the right idea. And then if not, then we'll like work it out together and see what we can find out. Does that sound good?
That sounds good.
Okay. Let me see what the quiz is, because if the quiz is anything like the last quiz, then
It's pretty close to the same.
yeah, it looks like it is. Do you have your answers up?
Yeah. Oh, I didn't put my quiz up yet. Should I put the quiz up?
Yeah, I'll probably just pull it up. We'll just go through the quiz because it's pretty much the same. Then we can get the answers and the problem solved at once plugged in.
Okay. Okay.
Okay. Okay, so number 2 is it's the 90% confidence interval for 45 and 105.
Right.
And so on that one, I got the answer is A. We are 90% confident that the true mean heart rate is between 45 and 105.
That's what I got.
Okay. So I think that's probably right. Okay, 3. This is about the researchers at University of Mississippi want to determine the reaction time. The researchers decide to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples, and they see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I put B, yes, the distribution of means is normal since the data has been determined to be normal.
And that's the one I got too.
Okay. 4, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And I think I put D, a confidence interval for the mean of differences using dependent samples, but using independent samples. But I was kind of confused on this one.
Right. I put D the first time, and then I went through the second time and put C.
Yeah, see, I did that too. I put C the first time, and then I went through and put D.
So I guess we have to figure out dependent versus independent samples, because on this study, it depends on what their first test was. So I guess we just need to kind of decide what dependent and independent mean.
Right. So dependent, like from my knowledge, is like they're like pairs that go together, and then you subtract the difference.
Are they pairs on this? Okay.
Well, it says researchers at university wanted to determine whether the reaction time in seconds to no-go stimulus of males differed from that of females. The researchers randomly select 20 females and 15 males to participate. So the reason I said it was independent was because because they're randomly selecting people, they're not like pairs really. So like knowing the male in group 1 doesn't tell you the female in group 2, but it does tell you that they're females in this case. But I don't know if that's the difference.
But this is what I'm thinking. we have different males and different females, but we need to know what their first test is in order to know the difference between the first and second test. Is that different?
Well, that's true. I think that's true for both independent and dependent samples, because you're going to have to find the difference of means in both cases.
Okay, well that makes sense, because that's what the thing I was thinking going, okay, no, wait a minute. We need to know the information, but we still they're not going to depend on each other. So I think you're right. I think it must be independent samples.
Although, like I said, I think it very well could be a dependent sample as well. So I guess we'll find out.
Dependent depends on what is in the group 1. I'm trying to remember.
Hey. Do you see this newspaper article?
Was it on the floor?
Yeah. Winston's student stress. Puppy, here you go. And our puppy was shit on shoes. Okay, so we think that it's D.
So let's see. Distribution. Yeah, I think it's D.
Okay. We will go for that, and if we get it wrong, then I guess we know why.
Right.
Okay. A researcher is interested in estimating the savings account balance of a customer at a large bank. She obtains the account savings balance of a random 30 customers. A 95% confidence interval for the mean savings account balance of the bank customers is found to be 3,402.08 and 4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Okay, for this one, I put B, which is obtain balances of 90 bank customers rather than 30.
Oh. Huh.
Which one did you put?
Well, I was thinking this way. So, which of the following produce a confidence interval with a smaller margin of error? So I was thinking when you increase the confidence interval, then you where is that at? So when you increase the confidence interval, then you increase the level. Oh, what is that? Increase probability of making it. What's the rule on the confidence level things? As the confidence level interval goes up, then what happens to the margin of error?
I was trying to think of that too. I was trying to look for my notes on that, but I don't remember.
I think it is that, let me look at that one. I think I just looked at that and then I thought I wrote it down, but then I didn't. I think that one said that the reason I'm wondering that is because I was thinking, I was looking at the answer as to increase it to a 99 confidence interval and see what would happen. But I'm pretty sure that is the opposite of what we wanted it to happen.
Yeah, I think if you go to the 99, it makes it bigger.
And so that's why my answer was none of the above, because I think you need to go down to a 90% confidence interval, and I think that's what would work. So that was the direction I was going, was changing
That's true though. That is true.
Interval. But obtaining 90 bank customers rather than 30 gives you a better what?
So I know that when you increase your margin, I mean, when you increase your sample size, your margin of error goes down. But it gets to a point where it's negligent. But I don't remember if 30 was that point or if. I'm trying to even remember what lesson this was in.
I think it's in lesson 10 because that's where I'm learning about. That's why I was looking at the confidence levels.
Okay, let me grab my notes from lesson 10 real quick.
Yeah, I think that is the deal. Which of the following variables produce decrease?
Yeah, it's in my top drawer. Let me see if I can grab my notes. You say it was lesson 10, you think?
Yeah, I think it's lesson 10.
Okay, I found my lesson 9 stuff, but where's my lesson 10 stuff? Lesson 11, lesson 10. Okay. I remember writing this down, but I haven't been able to find my notes, but I just found them. Okay.
It says n size and width of confidence interval. If the n size goes up, the interval goes down.
Okay.
So that's what you're thinking.
Right. So, and I got, just like you said, smaller percentile equals smaller margin of error. And then how does the margin of error for a size of 50 compared to 100? Margin of error gets smaller when it's size 50, or when it's 100 versus size 50.
So it would be B, because
Yeah.
I was saying none of the above because it wasn't 99, because it would be more like 90.
Right, which is true.
So that would be false, but obtaining a higher n would be true.
Right.
So I think you're right.
Okay. Okay. Number 6, factory propeller shafts. I put A.
I put A also.
Okay, so we both probably calculated it right then.
Yeah.
99.8. Okay. 7. I put A as well on this one, but I was not sure on this one how they even got this.
Okay, so we need to find where it says, where is the thing that says how you get N? What lesson was that in? Do you remember? If we have everything but N, what's our
Well, okay, so
explanation to get N?
So here's what I was confused about here is that because it gives you the margin of error in this case. So I think it's the margin of error formula.
Remember that we have that equation that tells us how to get N if we have everything else, but we just need to get N?
Oh yeah, what is that equation?
I know, I'm trying to see let me see if I can.
Because I was getting confused because I know that I have the margin of error, so I could put 0.001 equals the z-score times the mean divided by the standard deviation divided by the square root of n. And I figured I might be able to find it that way, but that wasn't working because we don't know the mean.
Well, we do know the mean, don't we? Isn't the mean like 1 gram?
Oh, is that the mean?
Yeah.
Oh, I didn't know that was the mean.
So is that I'm trying to look through my stuff to find out where that N calculation is, because I know we have it. But it sounds like that might be it. But let me see if I can see it. I don't see it in 11. N equals Z times the standard deviation over M.
M is your margin of error.
Right.
So it's
N equals
1.96.
Z times O over M. Okay, so then that would be, okay, we've got
Times your
Z is what? Z is 1.96 times standard deviation is 0.01 over M is what?
0.0001.
0.001. So we just have to do that calculation.
So what was that formula again? Will you tell me it again?
It's N equals Z with a little star thing
Okay.
times standard deviation over M.
Okay. So that would be 1.96 times 1 divided by 0.00. Is it 3 zeros?
Times standard deviation is 0.01, right?
Yeah. Oh, yeah. That's 0.01. Sorry.
Oh,
Divided by 0.0001.
Divided by 0.0001. I got 196.
I got 196 too.
Okay.
So,
So is that, did we just, I mean, the answer, there's an answer that's 1960.
yeah, I think it is that one.
I'm just going to do it one more time. So we go 1.96 times 0.01 equals divided by 0.1231. 196. I guess it doesn't matter if you put an O after that. Oh, wait. It does.
It would in this case, but I don't know if it really matters because
Do we use the gram in there?
Maybe, what is is it 1.960? Yeah, huh.
What if we put the mean in there instead of the standard deviation? Maybe.
Yeah, try that.
Try that and see if you get that. And I'm going to look and make sure that's really that's the N I had written down.
So that gives us actually
A totally different.
No, it gives us the same number with an extra 0.
Oh, that's funny. So it's probably that number. I'm wondering why
We're not getting that.
that exact thing. It's 12 ounce. Do you see anywhere in your stuff where the N formula is? I'm just trying to make sure I wrote that down right.
I don't see where I put the N formula, but I did put the margin of error formula. I'm going to try to solve it based off of the margin of error and see what I get.
Okay.
.96 times 0.01 divided by. No, I got the same thing. I got 1.96.
Okay, well,
I think that's right. That's what.
that's probably the right answer. Maybe I'm just gonna look that up, make sure before I take the regular test. But
Okay. 8. Number 8. On this one, I put A. This one's the one about.
yeah, I put A too.
Okay. Number 9, I put B.
Yep.
P-value less than alpha. 10, I put A.
I put B, and I don't know why here. Okay, group of statistics students want to determine if students in the same apartment buildings get better grades than students in others. They collect GPAs. Sample size of 15 from each of 4 different random buildings. So there's 60 samples, right?
I don't know, maybe. I thought it was just 15 from all of them.
A size of 15 from each of 4 different sample buildings. That's the confusing thing to me.
Yeah, that was
The data
confusing
for each
to me.
apartment building are bell-shaped with no outliers. Standard deviations are nearly equal. So you put yes, it's enough data. They're bell-shaped. There's no outliers in the sample standard. Okay, and then I put is because there's the central limit theory.
Which
Yeah,
would make
I thought that at first too, and then I'm thinking, oh yeah, there is 60. So we have
15 times 4 would be 60. That's true.
So it is A or B, but I don't know if it means that there's 15 total or there's 15 from 4, which means there's 60. But it did give us that a fact that there is,
Variances are equal.
yeah, that the variances are equal. So that makes you think that it's A.
Right. And the reason I put A2 is because it says the data were bell-shaped with no outliers. But here's the thing. With an ANOVA test, isn't the data supposed to be right skewed?
Oh, is this an ANOVA test?
It is an ANOVA. But it's supposed to be normal. That's what I don't get, because they say with an ANOVA test, the bell is right skewed, but they still want it to be normally distributed. So you think it'd still have to be a bell shape.
Well, but it's not a bell shape. Oh, I guess it can be a bell shape if it's right skewed. But
Yeah.
I thought bell shapes aren't right skewed.
I thought they were too. But with an ANOVA test, one of the things that has to be true is the variance have to be equal, and they have to be normally distributed. So that's why I put A, because it says the variances are equal, because that was the second thing that they said.
Right. Oh, it says it's bell shaped on the ANOVA test.
So
It's
yeah.
right skewed and it's bell shaped.
Okay.
Negative. So, but it has nothing to do with that there's 60, and so it's just right, because on ANOVA we have to check other things besides that.
Yeah, just because we have to check that the sample variances are nearly equal.
So we have to do that. So that
Yeah.
having it be 60 wouldn't be enough.
Yeah, it'd be enough to tell you that it was normal, but not enough to tell you that.
That an ANOVA test is okay. Okay.
Yeah,
Good.
that's why I put that.
I think you're right.
Okay, number 12. I put D, or number 11, sorry, I put D.
Oh gosh.
I don't know why I put D. Why did I put D on this one?
I put B.
No, A. I think I put A. Let me see. Yeah, I actually put A. Sorry.
Okay. So
So you
type
put
1
B.
versus type 2 errors.
Okay, let's look that up.
So a medical researcher is working on a new treatment for a certain type of cancer. Their average time is 2 years. So the null hypothesis is that the average survival diagnosis is the same for the new and standard. In a trial, she tries the treatment on 3 subjects who have average survival time of 4.5. Even though the sample is small, the null hypothesis would be rejected. Consequently, she rejects the null hypothesis, but in a future study, it's determined that the new treatment does not increase the mean survival time.
So I put it's a type 1 error because
Gotta be one. I didn't read that last part. I thought that I didn't read the last part right. It is a type 1 because when the null the null is true and it gets rejected, that's a type 1.
Yeah.
Okay.
Usually, if it's asking you an error, if they reject the null, it's type 1, and if they fail to reject it, it's type 2.
So if they reject it and it's true, that's a type 1.
Yeah.
Okay.
Okay. 12, I put D. By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yep, that's right.
Okay. 13. I put D on this one as well.
Okay, I didn't do this one. So
Okay. So the way that I got this one was I just found the p-value and then put it into the I found my z-score and then I put it into the normal probability applet.
okay, so our z-score is the mean in here is
1.53 minus 1.
minus the u, which is
1.5.
0.5
Yeah, 1.5.
over the standard deviation is
0.17.
7 divided by n, which is 100.
Yes.
Square root of n.
Square root of 100. Yeah.
So I'll just try and do that. That's probably, I'll get what you got, but I'll just do it for the heck of it.
Was this z-scores were in this lesson, right? This wasn't last test.
Yeah, z-scores was in this lesson.
Okay.
Okay, so I got my answer is 1.765.
Yep. And so this is a right tail test. Is that correct? Because the little tail is facing the 1.5.
Oh, did you use your probability app for this?
Yeah.
You go in here, and then we haven't done this forever. So we use this 1.765 down on this little thingy. 765. And then we are trying to decide.
It's a one-tailed test because
it's higher. We're trying to decide if the nicotine is higher. So then we do just
shade the area to the right.
And so then it would be 0.0388.
Yeah. And so the level of significance for this one was 5%, so 0.05. And this is 0.03, so I said reject the null hypothesis.
Because it's lower.
Right.
So that's A.
It's D because H null is 0.
I read that's A instead of O. Okay,
yeah.
Sorry. They were trying to,
good.
and they would have because I didn't look at it close enough. I can't see that good. Okay.
Okay. So then 14, I put C. Because it's male but to female. Which one did you put for 14?
And this is awful to tell you, but this is as far as I did on the quiz so far.
Oh, okay.
So these I haven't done yet, so
that's okay.
So you would look at the number of hours worked for wages by male and female. You would look at like a random for 100. What is the correct statistical? So we're doing a paired sample t-test.
I did because they're trying to compare male and female.
Yeah, I think that's right. Okay.
15. Let's see what I put on this one. I put D on this one. So an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs.
Stop for 1 second. Stop for 1 second. Okay, this I think is an answer to the one we were worried about before. On number 13 on the review, which is it decides one sample z-test, one sample t-test, and dependent samples or matched pair tests or independent samples. So remember how we were trying to decide the difference between dependent and independent? Dependent is matched pairs and independent isn't a matched pair.
Right.
So I think that's the difference.
Uh-huh.
is dependent sample if it's a matched pair, which means that you have to have the brother and the sister, or the mom and the dad, or whatever.
Right.
And independent, it's still a pair, but you don't have to have a matched pair, right?
I think you're correct on that. So I think these are dependent.
So, but the one that we did before that we were wondering if it was independent or dependent, I think that answers the question right there. That's the difference between the two.
So it would be the one before would be independent then?
Yeah,
Okay.
yeah. So I think that gives us the answer to that.
So in this one, I said it was a dependent because if you select a brother as to compare his academic achievement to his sister, you must include the sister.
Yes,
That's what I put for 15.
yes.
Okay. 16. 16, I put A.
Okay, again, I haven't done this, so I'll have to look at it. The soil scientists collected soil samples from field. Oh, is this the exact same question as the one on the quiz?
I think, wait, was this one on the quiz? It might have been.
Soil collected soil samples, dissolve organic molecules,
You have to use the dissolve.
95% confidence interval, the data file. Oh yeah, I didn't do this one at all. So I don't know if you want to just.
If you want to open the data
files, or do you want me to do it?
That's fine. We can do it again if you want to open the data file.
Yeah, because I'm sorry. I just my day was really crazy yesterday.
So I don't get like the difference between when you know the standard deviation when you don't know the standard deviation. Because like in this lesson, if you open the data file up, it just gives you a bunch of numbers, and then you could calculate the standard deviation off of those numbers, couldn't you?
You could. Let's see.
Because like, you know how we were doing that in SPSS at first? So you would get a standard deviation. I don't know how to tell the difference between if it's not known and if it is known.
All right, let me get this open and then I'll try to understand what you're asking. Okay, so this is asking me to do what? Let's see.
Yeah, so this is asking.
4 types of this. Oh, if it's known or not known.
Yeah, basically, because it's not a difference of mean sample, because you look at it and it's only one. It's just the carbon levels. Dude, go. So like in this one, I feel like you could get your standard deviation. It's known, you know what I mean? But I'm not sure if like they have to tell you it for it to be known, or if they.
Let's see. We have a standard deviation on this test.
Right.
So the standard deviation is. Oh, I see what you're saying.
So that's where I was getting confused.
So this test, he collected random samples. Each to solve are an important part of this. Okay, so this one okay. He collected random samples and he dissolved a level of each sample.
Mm-hmm.
I think, is there a difference between when you don't get to collect very much, so you have to just do different tests on the same sample? Is that the difference, is when you have to use one sample and do it over and over versus having a bunch of samples?
I'm not sure.
Just a minute.
That's why that's where I was kind of confused on this one. But I mean, as soon as I submit it, I'll know.
Okay, so I think that this is known.
I think it's known too. That's what I put.
Okay, so that would probably be A, because I think it's known because we have it and it's just right there.
Yeah.
But
And then,
I mean, unless they're trying to confuse us for some reason, which
yeah. And then the confidence interval, I just did descriptive statistics, and 95% confidence interval would be D, 11.16, 15.217.
Okay, yep, that's what I got on mine too.
Okay, you can close that one because there's like, you have to open like 6 different
Okay.
files.
Okay.
The next one is LA Hummers. Or it's, yeah, used Hummers, LA, New York is what it is.
Used. Okay.
Okay.
All right. Taken difference. Oh, so you have to do a difference one on this one?
Okay, so this is actually where I got a little confused too, because it doesn't give you, it can't be dependent, but it seems like it is dependent. But I think it is independent because the Hummers are in LA and New York, but for a dependent sample, you'd be able to subtract
Well,
New
but
York and LA. But in this case, you have to do an automatic recode because you can't. It doesn't give you the LA and New York to subtract, if that makes sense.
oh,
So when we were doing the last ones, if they were independent samples, we had to recode them. If they were dependent samples, we could subtract the two and find the difference and then just run a paired sample test for it.
right.
But in this case, I don't think that knowing the Hummers price in LA tells you the difference between the Hummers price in New York. So I think they're independent, but I don't know.
Listening curves. We want to know if there's a difference in listening between the Hummers and the Hummers creating it. Well, that's what we're trying to figure out, if there's a difference between LA and New York.
Right. So how to find that, I'm not sure. Other than
It's between LA and New York. So how you do these ones is you go, what is it that you do to do the difference?
right,
Computer variable?
yeah, you compute variable, but you're gonna find that there isn't you can't subtract anything. If that makes sense. It only gives you price. It doesn't give you like New York price versus
price minus. So you can't go price minus what?
right.
Oh.
By.
So you'd have to recode it to be able to do that.
And so, but you can't recode it to subtract is the only thing that I found problematic. So I recoded the city because that's.
So recode the city.
Yeah.
To recode city recode.
And then, so now we know between New York and Los Angeles. But see, if you do a recode, the only compare means test that will work is a independent sample t-test.
So a one sample t-test? Oh, independent sample t.
Yeah, because if you go, because that's the only one that'll allow you to define the groups.
And then the group variable would be city.
One and two, or yeah, city. So
would you do city and then define it as 1 and 2?
Yeah, I put city code 1 and 2 because
city code. Yeah. Okay.
because we've never done paired sample t-tests because and you can do those in SPSS, but the way that we do them is we subtract, right? And we get a difference, and then we put it into the one sample t-test and just run the difference. But in this case, like, we can't do that. Which is why I put
we put city code 1 and 2 in. Okay, so what it's asking us what now? Let's get back to what it's asking us.
So it's asking us if the confidence interval test is using dependent samples or independent samples, because it's for sure not where alpha is known or unknown.
Right,
Although,
because that had nothing to do with it. So it's not A or B.
Yeah.
And so we're deciding if the confidence interval for the mean difference is using dependent or independent. So when you do use dependent samples, it is what test do you use for dependent samples?
You subtract the mean and then you put it into the one t-test.
So you use a different one. And so when you use independent samples, we do what? What we just
do
did.
automatic recode. Yeah. So that's why I said that
It's got to be that one.
Yeah.
Okay. Because that's the only way we could get the test, so that's the answer to it.
Right, and then it gives you the confidence intervals at the bottom, which is -423 and then 5,417, which is an answer.
-423.
After you run your independent sample t-test.
Yeah, I'm looking at it right now. Yeah, the -423 and 5,417. So it's C. Yeah, I see that. I have that on there. So.
Okay, and then you got to exit out of this one now again.
Okay.
So I'm kind of interested to see, because I don't know how else you could run that test. That's where I was like, it has to be independent, because how else would you run it?
You have to. That's the only way you could run it, because you can't do the differences on there. They haven't got it ready for you that way, unless and even you can't even divide it. Really?
Yeah. I mean, it would be, I don't know, you'd have to really change the data a ton, and we haven't like done that ever hardly at all.
I know, which is weird, because the question they asked us last time where we had to like delete that stuff. I mean, what?
I actually asked our teacher, and he just barely emailed me back last night, I think, and he said that you just have to delete it like we did.
See, and that's why. So, could that test be something where we just have to manipulate the data, or?
I don't know. I don't think so. I don't even know how I could.
Okay. All right. So we are on this one, and do we have to use open bone density?
Yeah, exercise bone density.
I'm sorry I didn't get these done. That was really irresponsible.
No, it's okay. I understand. These things do happen. Okay, so 20 is asking us the same thing.
Okay.
But we know that this one's an ANOVA test, and the reason why is because we have a controlled group, a low jump group, and a high jump group. So there's 3 variables.
So there's 3, so we know it's ANOVA.
It has to be.
Yeah.
And then it asks us to calculate the test statistics. So in order to do that, we have to do the automatic recode again for the treatment.
Transform, automatic recode, treatment. Okay.
And then go to your one-way ANOVA test.
Analyze, compare.
And then treat code.
Dependent list is bone density. Treatment is factor.
Or yeah, treatment is your code, whatever you. So the test statistic would be, I got 7.978.
Okay.
When I ran that test. Is that what you got?
Right. It's telling me I got test statistic 7.978.
Yep, that's what I got.
So that's C.
Yes. And then the p-value is on there as well, and it's 0.002.
Yep.
And so, which would best express a conclusion with a significance level of 0.05, we would say that there is sufficient evidence to conclude that the bone density in at least one of the groups is different. So I think it's B. Yeah.
Yep, that's right.
Okay, this one. So this one we actually did in the quiz, but
Okay.
we can open it up and do it again. So this
Okay.
one is direct flight cost.
Okay.
So I never actually did this one. I just copied my answers from the quiz. So I'd be interested to do it because I ran out of time yesterday.
Okay. So this one we're getting into what again? Direct flight?
Direct flight costs. Okay. So the pressures of supply and demand act directly on the price of an airline ticket. As the seats available on the flight begin to fill, airlines raise the price. If the seats on the flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of the scheduled flight compared with the ticket purchased only 14 days in advance. Data were collected in the cost of a one-way ticket from London Heathrow Airport to a variety of destinations in Europe. The lowest published ticket price of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance, and then again for 14 days in advance. Perform a hypothesis test to determine if there is a difference in the cost of the nonstop flight when tickets are purchased 14 days in advance compared to 90 days in advance.
Okay, so this is one we had on our homework.
Yeah, on our homework. So, but here's what
And you looked up what it was?
I did, but here's what they're not the same, actually.
Oh, okay. Okay, okay.
They
So-
ask you, the other one it said, so in this case when it says, perform a hypothesis test to determine if there is a difference in the cost of a nonstop flight when the ticket is purchased 14 days in advance compared to 90. Do you do 90 minus 14 or 14 minus 90?
That's right. I think you do 90 minus 14.
That's what I thought too.
Yeah.
Because 90 or 14 compared with 90, didn't they say you always put the last one first?
Yeah, yeah. So you go in here and go transform, compute variable.
90
difference.
minus.
So 90
minus 14.
14. There you go. Okay.
Okay, so then we have our difference.
Okay, and so then we go analyze, compare,
And then one sample T.
One sample T.
Just put difference in the box.
Difference. And okay.
So the first question is, what do we use? And I put one sample T test.
Right.
But wait, is it a one sample T or is it? I don't know.
So we just did one sample T and we got that.
Yeah. Yeah.
Otherwise,
so I think
we
it
would
is
do
one.
what? So, what is the one?
It would be a dependent sample test because they're subtracted from each other.
So it would have to be one sample because all the other ones are independent.
Right.
Paired.
Paired is dependent. So, and they are dependent upon each other, which is where I was like, to get the dependent, you'd have to do a dependent sample test, but you're using a one sample T test for the hypothesis test. So I don't know what the answer is.
Okay, have you just click on that? Have you ever done that one before? I don't even ever remember doing that test.
Which one?
The compare means the paired sample T.
Yeah, we don't do it. I clicked on it.
Have we ever done that before?
No, we've never, because when we have a dependent variables, we do it just like we did. We subtract them and put it into the one sample T.
Yeah, because that would be the only one we could use because all the other ones are for independent, and we've never used the other one. So
But so I went to the homework, and
Uh-huh.
it does make sense. The homework says that it's a dependent sample t-test because you are subtracting the difference while you're using the one sample t-test to compute your variables. You did the subtracting already, which was the dependent sample test.
Oh, so we could do it the other way and it would work.
I don't know how to do it that way. They didn't teach us how to do that way yet.
Okay, so then what are you saying?
I'm saying dependent sample t-test because
the one sample t-test and the dependent sample, but we just did a one sample t-test on it then.
we
So
did,
why is
but
that different?
because we subtracted the numbers and created a difference variable, that is a dependent. Those are dependent variables. And so while we use the one sample t-test to run our tests, we inputted a dependent variable already. And because that's how they showed us how to do the hypothesis tests for those. But see, that's what the
So even though we did a one sample t, we had to use our dependent variable.
Right.
We had to use our difference.
Right.
Oh gosh, I'm glad you thought through that because I would have not. That would have been a.
And see, I'm not sure if like in the homework that's what it says, but if this is a different problem, I'm not sure. But I guess we'll learn our lesson in that case as well.
So in the homework, then you put a dependent.
I did, and it was correct.
Okay. So we're just going to put a dependent sample on this one.
Yeah.
Okay.
And then it says calculate your test statistic.
What chapter was that on? Do you remember?
It would have been. I can look it up real quick.
Is it chapter?
13.
Not 14 for
It's
sure.
not 13.
Is it 12?
It might have been 11. Or 12, yeah.
Yeah, this is the one that we're doing differences.
Yeah, it must be 12.
Yeah.
Yeah.
All right.
So
Okay.
we have our test statistic now on there, 1.685. And then we have our p-value, but is this a two-sided test? Can't remember. I think it's one-sided.
Let's see. It's saying seats available, discount, determine if there's a difference. So it's two-sided.
Okay. So that would be 0.096. And then our conclusion would be there is sufficient evidence with the 0.1 that there's a difference in the cost.
There is sufficient evidence that there is a difference. So B.
Yeah.
Yeah, that's right.
So I'm going to submit and then we'll find out. We can see what we did wrong.
Awesome.
Okay, we missed a couple. Let's look like. Okay, so 16 was the one about the carbon, and it says that it is unknown. So if they don't give us, so we know on the test now, if they don't give us the standard deviation, it is unknown. We cannot.
So it has to be given in the sample for us to know. Otherwise, we put it unknown.
Yeah, for sure.
Don't give sample. If they don't give us a standard deviation, it's unknown.
Yes.
Okay.
Okay, 14. Did you put paired sample t-test on that one?
Let's see. Which one? 14?
Yeah.
I put paired sample t.
Okay, so I did too, but it says in this case it is actually an independent sample t-test.
Okay, so why?
Says if you look at the mean number of hours of wages per week of male students and female students, what is the correct statistical procedure? I guess it's independent because just because you know that they're male doesn't mean that you're going to compare it to a female, if that makes sense. They're not like a family.
We're comparing the data, but not necessarily
The group. Yeah, that makes sense.
So the difference between paired and independent sample is if it has to have when the person has to be related to the other person, the subjects have to be related, not necessarily the data.
Yeah, the subjects.
So for paired sample, the subjects have to be related.
Yeah.
Okay.
And then 7 we missed. So I don't know how to do 7. That was one where we got 1.960. I'm not sure what we're supposed to do to get that.
Okay. So we got to figure out how to get the end of that one for sure.
And that's those are the 3 we missed.
Yeah. Good. All right. So I'll look over the end thing and see if I can figure that out. And if I can figure it out, I'll let you know.
Okay, sounds good.
Okay. Thanks.
Yep. See ya.
See ya.